Welcome to SiteSpect. My name is Tal Cohen. I'm the Director of Solutions Architecture here at SiteSpect, and this is an introduction to traffic routing. Without SiteSpect, when your PC makes a request to a website, let's say www.example.com, your PC does not know the Internet Protocol address or IP address for the website www.example.com. So it asks a device called a name server. That name server either knows the IP address or asks other name servers that it's connected to until one of them responds with the IP address. The name server then sends that IP address back to the PC. At this point, the PC makes a web request to that IP address. The request goes to the web server for www.example.com. I refer to the web server as the origin. The web server then responds with the requested content, which then loads in your browser. A minor change is needed when using the SiteSpect Cloud. The SiteSpect Cloud sits in line with traffic between the end user who makes a request to the site and the origin. This type of deployment is called a reverse proxy deployment. Requests are made through the cloud. The cloud issues a new request on behalf of the user to the origin. The origin then responds with content and sends that response to SiteSpect. It is at this point that SiteSpect modifies the content and takes measurements, all based on rules designed by you, the SiteSpect business user. This modified content is then returned to the end user's system. The SiteSpect Cloud is made up of multiple data centers strategically located across the globe. Within each data center, there is a load balancer and multiple devices that we call engines. The engines are what actually perform the work. They are all configured with the same campaign configurations. User sessions are managed through cookies. This architecture allows us to route a user's traffic to any SiteSpect engine, providing both redundancy and scalability. When a user makes a request, and that request routes to the SiteSpect data center, that request gets routed by the load balancer within that data center to the least loaded engine. That engine then makes a request to the origin. The origin then responds to that engine, at which point modifications are made and measurements are taken. The engine then responds with that modified content directly to the user, bypassing the load balancer for efficiency. This process then repeats for each and every request made by the user. This same process applies across SiteSpect data centers, adding additional layers of redundancy. Traffic is directed to SiteSpect by DNS. This is the same service mentioned before that informed your PC what the IP address of the origin was. When your PC asks its name server for the IP address of a website, the DNS server will eventually respond back with an A record. An A record is simply a mapping of a website's name to its IP address. When you deploy SiteSpect, the DNS record for the domain will get updated to what is known as a canonical name or CNAME record. A CNAME record is simply an alias. In this case, www.example.com resolves to www.example.com.ssop.net. Your PC will then ask its name server for the IP address of www.example.com.ssop.net, which will resolve to an IP address. ssop.net is a SiteSpect-owned top-level domain. One goal of our deployment is to always route users to the best performing entry point into the SiteSpect Cloud. This too is done through DNS. The DNS system shown here is part of a network of DNS systems used by SiteSpect to determine the best entry point into the SiteSpect Cloud. When your PC makes a request to its name server for the IP address of the origin, the closest SiteSpect DNS server will reply. Each DNS server sends health probes to each SiteSpect data center. SiteSpect in turn proxies those requests back to the origin, which responds with content. The DNS system then builds a list of IP address comprised of all the SiteSpect IP addresses that responded to those health probes. In other words, the purpose of the health probe is to inform each SiteSpect DNS server which SiteSpect IP addresses are up and functional. A second series of probes is then sent following the same process. This second series of probes are performance probes. The time it takes for these probes to respond is measured. The DNS system then orders the IP addresses from fastest to slowest. Lastly, the DNS system only responds with the top 2 performing IP addresses. If on the next series of probes the measurements change, the order will change as well. Using this method, your PC will always get the best performing entry point into the SiteSpect cloud. This method of managing DNS is called Anycast. As with any system, things go wrong, systems break. SiteSpect has built-in automatic redundancies and mitigation to handle these scenarios. Let's say that your name server was given the IP address of SiteSpect Data Center 1 and 2. But something happened in Data Center number 2 and it is no longer functional. Our DNS system will automatically detect this state change and simply stop serving that IP address. It will serve the next best performing data center instead. If all the SiteSpect data centers become unavailable, our DNS system will simply point traffic directly to the origin. We call this bypass mode. If you remove the health check object from your server, that too will trigger bypass mode.
We encourage you to reach out by calling or emailing us with questions about our products and services. As a client, you can reach out to us 24/7 for personalized emergency support, and you can always track up-to-the-minute status of our cloud environment by visiting our status page. Feel free to reach out to us anytime. Happy learning!